Assalamu alaikum everyone. Let's continue with lesson number 8, implicit differentiation and inverse trigonometric functions. Okay, by the end of the lesson we should be able to find derivatives implicitly and find derivatives of inverse trigonometric functions. Now, here's the steps on how to differentiate implicitly. So we will have an equation where we need to differentiate both sides of the equation with respect to x. And when we differentiate any function of y, then we need to multiply the derivative of this function or expression times y prime of x. Because we are deriving in respect to x, so whenever you derive any expression in respect to y, you need to add dy over dx or y prime of x. And then once you differentiate both sides, you can collect terms with y prime on one side of the equation and then factor out y prime, meaning take y prime as a common factor and then solve for y prime. So these are the steps to derive any equation implicitly. Here's an example. Find the derivative y prime implicitly. So the first step again is to differentiate both sides implicitly. And you can see the first term here, we have a product rule. So derivative of the first times the second plus the first derivative of the second. Now the second term here involving y, so whenever we differentiate, we need to multiply by y prime of x equals on the other side, the derivative is only 4. Alright, so let's simplify these two derivatives. This will be 2x y squared, and here we have 2y. Since we derived y, we need to multiply with y prime. So you can see we have two y primes here. All right, let's simplify the expression. So here we have x squared times 2y times y prime. And this can be simplified like so. And you got 3y prime equals 4. Now let's collect y prime on one side of the equation. So any term that doesn't include y prime, move it to the other side. And you'll be left with these two terms. On the other side we have 4 minus 2xy prime. Now take y prime as a common factor. You'll be left with 2x squared y plus 3. And to isolate y prime, we need to divide over this bracket here. So y prime, or the derivative, will be equals this expression. And that's it. Here's another example. We have sine of xy equals x squared minus 3. So again, what's the first step here? We need to differentiate both sides. What's the derivative for sine? It will be cosine of the same term times the derivative of what's included in the sine here. And on the other side, the derivative will be 2x plus 0, of course. Now, the derivative here is a product rule. So we can simplify it like so. Derivative of the first times the second plus the first derivative of the second. Since the second here is y, we need to multiply it by y prime. All right. Now, if we simplify the expression, distributed cosine xy inside. Now let's simplify it. Distribute cosine xy times y. And then plus cosine xy times x y prime. Okay, so now let's leave this term with y prime on one side, move the other term on the other side to isolate y prime. So solving for y prime, we need to divide over x cosine of xy, and this will be our final answer. So the derivative equals this expression. Here's one last example. Try to pause the video, solve the question, and then come back to check your answer. All right. So the first step is to differentiate both sides implicitly. You can see on the left side, we have a quotient rule. And this will be derivative of the top times the bottom minus the top derivative of the bottom. Since the bottom is y, we need to multiply it by y prime over the bottom squared. On the other side, the derivative here will be 4, and y squared is 2y times y prime. Okay, so to simplify this, let's multiply both sides by y prime to get rid of the denominator here. So multiplying both sides by y prime, this will cancel out. You'll be left with the top here, and then y prime multiplied with these two terms. Now we need to collect y prime on one side of the equation. So let's move this term on the other side and then get the term with y prime next to this one. And the equation will look like so. And now we need to factor out y prime as a common factor. And taking y prime as a common factor, you'll be left with x plus 3 plus 2 y cubed. Of course, we need to solve for y prime, dividing on this bracket, and this will be the derivative here.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Moving to the other idea here, find the location of all horizontal tangent lines for this equation. Now, the horizontal tangent line happens when the slope equals 0, meaning that the derivative equals 0. So we need to find the derivative, set it to 0. At this point, you will get a horizontal tangent line. If it's vertical tangent line, you'll do exactly the same, except it happens when the slope is undefined. So you see where it's undefined. Okay, let's focus on our question here. So the first thing to do is finding the derivative for this equation. And you need to do it implicitly, right? So differentiating both sides, you will get 2x plus 2y times y prime minus 3y prime equals 0. Move the term that doesn't include y prime on the other side. We need to isolate y prime, right? So now let's take y prime as a common factor, and you'll be left with 3 minus 2y equals 2x. Divide over this bracket, and this will be our derivative. Now to find the horizontal tangent line, it will have a slope of 0, and I know that the slope is the derivative. So let's take the derivative and see where the derivative equals to 0. And you can see it happens when the top equals to 0, and this occurs at x equals 0. So at this point, x equals 0, we have a horizontal tangent line. Now to find the exact point, we need to substitute this value in the original equation. So substituting 0, you'll get this equation, take y as a common factor, and using 0 property, it's either the first equals 0 or the other bracket here equals 0, which means that y equals 3. So the points here is 0 and 0 and 0 and 3. You can see in the diagram here. That's it. Moving to the last idea, the derivatives of inverse trigonometric functions. So in order to evaluate the derivative for sine inverse, we need to memorize the formula. And this is the case for each one of the inverse trig functions here. All right, so make sure you memorize these formulas. Let's practice on these two questions. Cosine inverse of 3x squared. With the first one, we need to find derivative of cosine inverse for 3x squared. Now, using the formula, just like a chain rule, the derivative of the outside, which is -1 over square root of 1 minus the angle squared times the derivative of the inside, which is the angle itself. Now this can be simplified after we distribute 2 inside, 9 x power 4 times derivative of what's inside is 6x. And this will be our final answer. With the second question, just use the formula. So 1 over 1 plus the angle squared. This is the derivative of tan inverse times the derivative of the angle. And this can be simplified like so. And the multiple choice will look in the simplest form like so. All right, that's it for today. Thank you so much. See you next time. Assalamu alaikum.